So yeah, I'm Alex Birmingham. I'm an engineer here at ExtraHop. Um, I've sort of been able to watch the company moved from the untamed JavaScript wilderness into the nice, orderly TypeScript world. It's been quite nice to watch, but there have been challenges along the way. Um, and I would say that one of the larger challenges has been dealing with unknowns, dealing with data that comes from outside of that orderly TypeScript application. So that's what we're going to talk about today. Okay, so you've got your strongly typed application. Everything's great. Your functions have type annotations on the parameters, on the return types. Inside of this locus of control, everything is wonderful. But then an inevitable problem arises in which a variable with an unknown structure enters an otherwise strongly typed application. So this could come from any number of different places. Here are some things that I like to model as unknown. And when I say that, I mean literally the type unknown that TypeScript has provided since, I don't know, 2.7, 3.0, something like that.
Who hasn't heard of Unknown?
Yeah, that's a good idea. Engage with the audience. I like that.
What is Unknown?
Sounded like a planted question.
What is Unknown?
Due to the fact that I know that you know. So let me get to that in a moment. Hold your questions. So in an application, we know that there are going to be some things that are unstructured, that don't necessarily have a guaranteed type. For example, if we were to JSON parse something, we have, at compile time, the TypeScript compiler has no comprehension of what JSON.parse on an arbitrary string is going to produce. Query string parameters, if we just read location.hash or location.search or whatever, location.search, I'm not sure about that one. Anyway, location.hash, certainly we're going to see a string, and TypeScript's built-in type library is going to model that as a string, so that's great. But often we like to put other data into the URI, and so in order to get that back out, we use a library like QS, or maybe we roll our own library for parsing the query string parameters or whatever, and we get an object out that has like key value pairs that correspond to the query string parameters. And we can go further with a library like QS, and we can have nested objects in the URI, and it all gets pretty complex. And we can't trust it anymore because, of course, the user can just type whatever they want into the location. Same goes for browser state, like local storage, cookies. I don't know, there's probably several other examples there that I didn't think of when I was writing this. Socket messages, untrusted API results, like a third-party API maybe. We sometimes do type checking. We sometimes do exhaustive type checking with our own APIs. It's probably worth mentioning, we haven't exactly found out where the line is there, because there are some things that we want to be flexible. Like we've done exhaustive type checking with our own APIs and then found like, oh, this is just another place where we have to go in and change the code when the API changes. So we haven't totally figured out what the right strategy is there with trusted APIs. That can also be really inefficient if you're type checking a huge JSON structure. But yeah, basically anything from an untyped source. So these are the things that I tend to model as unknown, and they're things that come from, they all have in common that they come from the edge of the application. So real quick, before we dive into some code and try and solve this problem, let's define some terms. So type narrowing, this is a term that describes what the TypeScript compiler is able to do when it infers that in a certain scope, a variable is refined to a subset of what it was. So for example, here we have this some value constant that I've declared, and it's either a string or a number. And we check to see if the type is string. And the TypeScript compiler is smart enough to say, okay, well, inside of this if conditional, some value is a string. Even though outside of this conditional, it's a string or a number. So we're able to call methods on that object as if it was a string. The compiler doesn't complain. And then we get back outside of that conditional block, and now it doesn't know, so it's going to throw a type error. Because you can't call slice on string or number.
What's declared?
So it's just a way of telling the TypeScript compiler that there's some like ambient variable that it should just trust is available. I think that legitimate usages are in like .d.ts files for declaring globals. But the way that I always use it is I'm trying to figure something out. I just want the TypeScript compiler to like take something for granted in my little workspace. Yes?
Does this work if you have like more complicated types? Like, for example, you have a type that's duck and another type that's goose that you've declared elsewhere in the code?
Yes. Yeah. Yeah.
The type of operator doesn't gain any magic, right?
Yeah, I wouldn't say that you can use the type of operator there, but type narrowing still works.
Type of doesn't come from TypeScript. It's a JavaScript.
Right.
How do we solve that? What about instance?
You might be able to use instance of in that case, or you probably would want to use instance of in that case. Assuming that duck and goose are classes. So another thing is type guards. So we pretty much do the same thing here as we did in the previous slide, except now we're defining our own isString function. IsString is a function that takes x, which is of unknown type. It returns x as string, which is spoiler to the next slide. X as string is the type predicate of this function, and it is if a function has a type predicate, then it is expected to return a Boolean at runtime. So this is our way of defining our own functions that assert types, and TypeScript will respect it. So yeah, this function isString isn't really necessary because you could just use type of x equals string, but yeah, it's illustrative to what a type guard is. And in fact, this will be something that we'll use later in the presentation. So. Type predicate, we just talked about this. It's the return type of a type guard. Here, x is string. And finally, one more term, generics. So generics allow us to write reusable functions, which can accept a wide variety of types, some of which aren't even known at the time of authorship. So for example, you can imagine being a TypeScript developer wanting to model like the array class. You don't necessarily know what the type of the members of an array are. But if you're doing like if you're writing the signature for something like pop, you would need to allow for some type to be returned. And this is how you do it. So in this case, we've written a function called getFirstItem. It takes a type parameter of t, which is typically inferred. You don't necessarily have to be explicit about that when you call the function, although you could. And then it takes x, which is an array of t, and returns t or undefined. And then the body of the function is just accessing the first member of the array. So in this case, we have a variable called aString. When we call getFirstItem with an array of type string, TypeScript is smart enough to, because of generics, to return string or undefined. And then in the second case, you have a number. We pass an array of numbers, and TypeScript is smart enough to return a number or undefined. There's also another case of type narrowing here where because a string and a number are both string or undefined and number or undefined respectively, we have to narrow them before we are able to use slice or to fixed. And we do that by wrapping that code in a conditional. So we've got our terms defined. Let's model and solve a case where a variable has an unknown type. So here we have an application state interface. It has a filters property, which is of type filter array. The filter array looks like this. It has three required properties: field, operator, and operand, and one optional property label. It's pretty straightforward. Other than the optional property and the type union of string or number or Boolean, this would be something that you would use in, for example, like a page that has a search. And the user is able to add filters to the search. This interface is actually taken directly from our code base, so it's real. Specifically, the reason why we're running into this unknown issue is we want to persist the filters to the URL. So we put them in the query string in code that you can't see here. They're in location.hash, serialized as a string. And then here, we're reading them back out again. And so we're using qs.parse. Again, QS is a query string library for serializing and deserializing objects for the URL. And we're assigning it to this variable called untrustworthy. Fun fact, question mark, is that qs.parse actually returns any, which kind of sucks. So I'm casting it to unknown because it's safer here. In our own application, we have some wrapper functions that return unknown as opposed to any. Let's see here. Okay, so the solution to moving from unknown to that nice application state interface that we looked at earlier is a type guard. So we've got this isApplicationState function. It takes x, which is unknown. It returns x is application state. That's the type predicate. And then it does much stuff. And it actually takes more code than what's shown on the screen right now in order to fully define this type guard. So what we've got on screen right now is we've got isApplicationState, which says x is an object, x is not null because type of null equals object for God knows what reason. hasProperty on x and filters. So x has a property called filters. We don't know what it is, but it has that property. We have to define that function because x.hasOwnProperty is not typed such that it narrows the type of x. So we have to define our own function for that. We can't use hasOwnProperty. Some people actually extend the hasOwnProperty interface over the built-in types that that TypeScript provides to you, but we don't do that. We just have a wrapper function. So then we have isFilters, and this goes deeper on the filters property and says it's an array, and that's the first bug. It's supposed to say x.length is 0 or x.every is filter. So yeah, that's a bug. It's supposed to be saying basically it's either an empty array or it's an array of filters. What is filter, you might ask? That is on the next slide. So it's getting worse. Yeah, it's hard to imagine wanting to code review this or write this function over and over again against various domain objects that you're modeling and serializing to the URL or whatever. Okay, so now we redo the type of x equals object and x not equals null, and then we say it has the property of field, and x equals field equals string, same with operator, same with operand, but also operand can be a string or a number or a Boolean. And then the label is a kind of a weird case because it's optional, so we either say it has it, or the type of label is what we expect. I don't know that this is even correct exactly because it could have the property and be undefined, and that would still match what our interface was. It's all kind of messy and unpleasant. There's actually a bug that I intentionally put into this function. Can anyone find it? It's probably hard because you don't actually have the original interface around anymore, but
The label will supposed to be string on.
yep, that's right. Yeah, nice catch. So yeah, I mean, the other problem with this sort of thing is as you're like handwriting these laborious type guards yourself, is that you can very easily write a defect. And that's exactly what's happened here. The compiler is not going to stop you because it doesn't know what you're trying to do. It's even worse if x is any, by the way, because then we could do all sorts of things like try and access properties on it prior to validating that it's not null or undefined, things like that. So yeah, we got there, and now we can use our isApplicationState function, and if it's not what we expect, we can throw an error, and we can continue, and now our type is narrowed to application state. And we're in good shape. But again, this is all very unpleasant and after you've done it, you don't want to do it again. It's mind-numbing, it's hard to code review, and it all gets worse with nested objects and arrays. So what can we do to make this situation better? What we decided to do something like a year ago was to create that hasProperty function that we looked at before, but extend it a little bit in order to make it more ergonomic. It requires less boilerplate when we use it, and just make the resulting type guards a little bit easier to code review and grok when you look at them. Ideally, you should be able to look at one of these type guards and be like, line it up next to the original interface and be like, yeah, that does what it's supposed to do, without digging through imperative code. So hasProperty now takes an object, which is unknown. It takes a prop name and it takes a type guard. A type guard is just a function that takes one parameter of type unknown and has a type predicate of the parameter is t. So through the magic of generics, what this allows us to do is call hasProperty with anything, because anything can be assigned to unknown, a property, and optionally a type guard. So if we just care about saying this is an object and it has this property, we pass obj and prop name. If we also care that the property has a value of a specific type, then we can pass a type guard. And that type guard, again, looks like this. It's a pretty easy contract to fulfill. Like if you're trying to type guard like lots of strange different things, at the end of the day, all you need to be able to provide is a function that takes an unknown value and returns a type predicate on that value. Note the sweet tslint comments because we ban any in our code base. Right there. But I actually don't think that you can write this function without any, so sometimes you have to. And then let's not forget optional properties. We have another function for that. We looked at just having one function that basically switched between the two cases, and the ergonomics weren't what we wanted. So we landed on having two functions. Okay, so this is the tough part. We are going to fix those that earlier, uglier code that we looked at live right now. Okay, so this is all the code that we were just looking at in the slides. We've got the interfaces, we've got untrustworthy, isApplicationState is filter, hasProperty, isApplicationState, throw new error, ApplicationState has been narrowed now, so we're good. I think I'm running low on time, so I'm going to try and get through this quickly. Everybody knows it's easy to code when people are watching, so this should be relatively straightforward. So the first thing that we're going to do is we're going to get rid of that hasProperty function, the local one, and we are going to import our hasProperty function that we've already written. That's the one that was on that previous slide. So now, and the interface is the same in terms of the first two properties. The first property is the object that we want to assert has a property, and the second is the prop name. Then we're going to start with filter. And so x is unknown and x's filter are the parameter and the return type of this. So first of all, let's get rid of type of x equals object and x not equals null. We're going to say that hasProperty x and field should also take an argument of isString. This is where our isString function actually comes in handy because we can't do something like type of string unless we were to define this inline, which we don't want to do. So we're going to import that. And now, not only does x have the property fields, but it's of type string. So we can get rid of type of x.field equals string. And then we do the same thing for operator. And then we want to do something similar for operand, but this is a little bit more messy. If you guys remember, operand actually is a string or number or Boolean. But again, hasProperty just takes a pretty simple type guard, an unknown parameter with, the parameter is t. So we were able to define a higher order function called isAnyOf that accepts multiple type guards. So here we will say hasProperty x operand isAnyOf is string, is number, is Boolean. Oh man, how do you do things on a Mac?
Command dot.
Command dot. There we go. Okay, so is number, is any of. Okay, so now if we get rid of some of this other code and we mouse over x.operand, it now knows that x.operand is a string or number or Boolean because of the hasProperty and isAnyOf. So we can get rid of this type of check, and then we probably do something like this where we get rid of these comments. How do I multi-cursor?
Command L.
Command L, that
Command D.
is awful.
Command D.
You highlight the 2 slashes and then the command.
Yeah, alt sounds much better. Okay, so we probably get rid of that. Okay, so now we have an optional property. So let's go ahead and ignore that this whole line of code here for a moment, and let's write its replacement above. So we'll say has optional property x label is string, and that takes care of some of the nonsense that we talked about earlier of, well, it could be there and be undefined, or it could be missing the key and we don't really care which. So yeah, isFilter is quite a bit smaller now. This is the original, and now it's this. And I don't know, from my perspective, it's pretty close to the interface. It's pretty declarative. I could look at this and it reads like a declaration of the filter interface. So then we go up here and we're sort of working backwards from filter all the way up to application state. So isFilters is asserting that X is an array of filters. This is a little bit trickier, but again, we have some type guards to help us. I feel like there's like an is list of that we've defined somewhere. Takes a type guard.
Just a type guard.
Yeah, that doesn't make any sense. Oh, so isListOf would take, it does currying, so it takes the type guard and then it returns another type guard. And through the magic of presentations, it just works because we happen to already have an isListOf. Not really relevant to the hasProperty thing, but necessary here. We do something very similar with isApplicationState, where we get rid of this. We say hasProperty x filters and isFilters. And then we probably get rid of isFilters and just inline this and do something like isListOf filters except down here. And this uses isListOf filters, and we get rid of isFilters. Okay. So yeah, now we can do something very similar to what we had before, where we're calling isApplicationState, but inside of isApplicationState, we've got a pretty declarative, concise definition, easy to code review, and so on and so forth. Whereas previously, we had this, which is pretty objectively bad, I think. And yeah, that's hasProperty. I'm not going to go back to the slideshow because I'm afraid of what will happen. I will say that I didn't have any more slides, so you're not missing anything, except that I was going to say that there apparently is also a type guard generating library. So if you're interested in adding like a build step or a manual step, you can also apparently take an interface and have a type guard generated for you, which I like the idea of. It adds, it reduces the amount of code that you're writing even more. But that library didn't exist when we wrote this, I don't think. And in any case, it's sort of an interesting exploration of TypeScript. So yeah. That's it. We do plan to make this available via open source at some point soon. So if you're interested in that, let me know or let Alex Berner know, and we'll get back to you. I'm not sure who's next. Do you?
Tyler. Oh yeah, questions? Questions?
Oh yeah, questions?
Yes, I just had one question. That was great, by the way. It seems really useful. But when you were talking about, what was it, the type predicate, where it's like the arguments here, and then colon, and then is filter or whatnot, or like is duck, is goose, to go back to this example. Does that force you into just the binary? It is either a goose or it's not a goose, or do you have options, like return options, where it's like it does its type checking, and if it's a duck, then the type returns a duck, and if it's a goose, returns its goose, or does it force you into that on or off?
So you can do whatever you want to in the function, but at the end of the day, you have to return a binary Boolean.
So in your case, if you wanted one of the two, you'd have to do two, like one that just does duck and one that just does goose, and you'd have to say if duck or goose. And then within there, it would be duck or goose.
You could do a union of the two.
Oh, like
You can do that as
goose
well.
return
Yeah.
is duck union goose?
Yeah.
Probably.
Yeah, you can do that as well. Yeah. Sorry, I didn't totally understand the question. But
Oh.
is that what you're asking? Is if you could like return or use a type union in the predicate?
Yeah, that's the sort of thing. That's the answer I was looking for, which is like have a list of options, and it'll narrow from all these different animals to the one specific animal towards the end, and that was totally the answer. how to implement it. I'm not sure, but just the fact it's named is really cool.
Yeah, you'd be able to narrow it to like duck or goose. But I think in general, if you are defining type guards, you generally define them at like a really low level and then compose them.
Cool. Thank you.
Okay, so I think we have to start recording again.
Oh yeah, so just set that up.
Do you want to do that while I answer any other questions?
Please make it open source. That'd be awesome.
Yeah, I mean it's not a lot of code. We could probably, if anybody really wants it before it becomes open source, we can probably get something to you.
I have a question. If this goes open source, how can we find it?
Well,
We have a GitHub.
we have a GitHub, yeah. But we don't have much on it yet.
We got a few things. We got RPCAPD. Everyone here needs that. Or like
remote data.
and remote data.
Everything is so big. We have TS remote data, that's true. That was one of our presentations at our first meetup.
TS remote data React.
TS remote data React.
There's a new version already.
It's like an additional helper that sits on top of remote data.
You can just drop the React component in, it'll automatically take care of the loading and stuff for you. It's really great.
Yeah, it's sort of suspense-like, right?
Yeah, there's this remote suspense. We'll have to have Ted come back and give another presentation about remote data React. But in the meantime, that was Alex. Thank you, Alex. You want to come